Okay, so question 10, I'm going to start off with y-intercept, because all I have to do is plug in 0 for x and solve. So I get 0 over 24. 0 divided by 24 would be 0. And I know the origin's not just the y-intercept, it's also an x-intercept, so I anticipate this to be part of my answer later. But for x-intercepts, vertical asymptotes, and holes, I have to know what numbers make the numerator and denominator 0, which implies that you factor the numerator, always the GCF first if it has one, and then it was the difference of two squares. The denominator also had a GCF. Okay, and the purpose of that is so I could quickly see 0, -4, and +4 make the numerator 0, and 3 and -2 make the denominator 0. -4 never equals 0, so that doesn't give me another one. So there's no number in both lists, which is how you get a whole. There's 4 numbers that make just the numerator 0, so those give you x-intercepts. I already knew this one. And there's 2 numbers that make just the denominator 0, which gives you vertical asymptotes. Also, this is good for domain, because domain, you need to take out any number that makes you divide by 0. So the numbers you can plug in would be numbers less than -2, between -2 and 3, and bigger than 3. Horizontal asymptote, you have to compare the degrees. The degree if the denominator is bigger, it's y equals 0. The degrees are equal, you do leading coefficient over leading coefficient. And if the degree of the numerator is bigger, then it does not have one. But if the degree is 1 bigger than the degree of the denominator, it's going to have a slant asymptote. So this one had a slant asymptote. And when that happens, which is not super often, but we have to use long division to find that equation. So, looks like we need a -1/4, because a negative times a positive gives me a negative. Oops, scratch that. A 4. 4 times 1 gives me 4, and an x. Oh, I got these backwards. Sorry. Cause some problems. Denominator divides into the numerator. Okay, so I need an x, because x times x squared gives me x cubed. I need this to be negative, because negative times a negative gives me the positive that I need, and I need this to be 1/4, because 1/4 times 4 gives me 1. So then I also multiply it by this to get -1x squared, and then multiply it by this to get -6x. Change the signs and add. These are not like terms, so don't force these together. There's 1x squared. These are like terms, so you can combine them. Minus 10x. And it looks like it'll go one more time with the long division algorithm here. It looks like another negative, because negative times a negative gives me a positive. Looks like 1/4, because 1/4 times 4 gives me 1. And I don't need any more x's, because I've already got x squared and I want x squared. Alright, then technically you need to multiply it to this, and this. Change the signs and add. However, I could tell that this was going to be the remainder anyway, and the remainder is important sometimes in mathematics, but for slant asymptotes it's not, because it will just be whatever the quotient is. Y equals -1/4 x minus 1/4. Now again, some of these long division questions are a little bit harder than you'll see. Usually you don't have to deal with fractions, but if you spend a little more time on it, you should be okay. Alright, throw all this onto the graph. we've got one y-intercept, 3 x-intercepts, we've got 2 vertical asymptotes, we've got a slant asymptote that's in the form mx plus b, so y-intercept, and then down 1, right 1, 2, 3, 4. Okay, and then you're encouraged to make more points. Sometimes we need more points, sometimes we don't need more points. This one, I think we're going to need at least one more point. So let's start off with the parts that you should know. Whether it's a horizontal asymptote or a slant asymptote, that tells you how your graph is going to approach at the far left and far right of the graph. Based on these directions, this one's going down, so this one's going to negative infinity and this one's going to positive infinity. Based on this direction, it goes up on the right and down to the left. I know this one has to hit this point, and okay, I guess I don't need any more points. This can connect with this. So a couple people were asking me about this a few minutes ago, and this is a very common misconception. A graph right here, a graph can cross the horizontal asymptote. It can also cross a slant asymptote. It doesn't happen very often, but it can. All a horizontal asymptote and slant asymptote tells you is what I have highlighted, what it approaches on the end. It is fair game to go through the middle of the graph. It can cross it somewhere in the middle. Okay, and of course we want to try to graph this guy, make sure the graph looks okay. If it doesn't look okay, then it at least gives us a few hints about what we might need to reevaluate. Okay, so there's their graph. Here's my graph. And those look pretty good. So, again, that doesn't give you 100% confidence that everything above was correct. Like your domain could still be written incorrectly. There could have been a hole and the calculator's just not showing it. But if your graph looks the same, then most of it should be fine.